Hi there, folks. Today we're looking at trigonometry and area. And really all today is kind of looking at all these areas that we already know how to find the area of these different things and the formulas we already know how to use. But what we're going to do is we're going to use trig functions to find any missing pieces that we might have. All right. And we're only going to use our right triangle trigonometry for this. We're not going to be getting into law of sines or cosines here. And so the idea here is as I look at each of these figures, as I look at each of these shapes, I want to break this thing down into right triangles. So I want to split the shape into right triangles because by having those right triangles, I can find missing pieces, okay, using my trig functions. So I break things into right triangles. I use trigonometry to find any critical measurements. So whether this is a regular polygon and I need something like the apothem, or whether it's a regular polygon and I need something like the perimeter, I need to work my way back across to that, or whether this is a triangle and I need to find the altitude, I break the shape into right triangles. I find the measurements I need using trigonometry, and then I use the appropriate formula to find the area, doing exactly what I've done in the previous lessons, okay? And so if I look at an example like this guy, it says find the area of each regular polygon. So I know that I have regular polygons here. And we found some of the missing pieces to these previously. Most of the time they were easy things like finding the perimeter, or they were simple things like when we broke the figure into pieces, I ended up with things like special right triangles, so I could just find the missing measurements without doing any trigonometry. But for these, I'm not going to have that luxury, all right? These aren't going to break down into those special right triangles necessarily, and so I have to use trig functions in order to find the missing pieces. So it's very similar to what we did before, but instead of using special right triangles, I'm going to have to use right triangle trigonometry. And so when we look at like this first example here, if I were to identify maybe like the center of this thing, so let's say the center of this guy is right here. If I were to start kind of breaking this thing down into triangles, so drawing the radii for these, as I draw each of those, what I get is a bunch of isosceles triangles, because remember, all the radii need to be the same here because this is a regular polygon. And so as I look at this thing, I can find the measurements of some of those pieces. I don't really need the radius of this thing. What I need is the apothem. And so if I were to draw one of those, so here's the apothem right here, it's really the altitude of one of those isosceles triangle. And when I draw that thing, remember this is a right angle, what I give myself right here, if I kind of highlight it in purple, is I give myself a right triangle. And I could go through and split all of these triangles using the apothem and using the altitudes of those triangles and have a bunch of right triangles, but I really only need that one, okay? And so what I need to do now is I need to break this down in terms of its angles. So I need to start finding the angles of this thing. So let me erase this guy right here. Let's say I wanted to find just this whole angle right here. And so because this thing is a regular polygon, I can use this formula of 180 times n minus 2, where n is the number of sides. And then if I want to find each value, I just divide that by n. Okay, and you can kind of do that in two separate pieces. I usually do it in two separate pieces. I think about, okay, the sum of the angles, let's see, that's 10 minus 2. And so when I plug that into the calculator, that gives me a 1440. But that's the sum of all the measures of the angles. Well, if all those angles are the same, I just have to divide by 10 in order to find the measurement of each of these angles. So I get 144 degrees for this guy right here. So each of those interior angles is 144 degrees. But now I have to say, okay, if I were to redraw that radius, it splits that thing in half, meaning that each of these angles must be a 72 degrees. Okay? And as I kind of think about how that affects this triangle that I have drawn in purple, let me kind of draw this off to the side. Remember, this right here is the apothem, this side. And that's a right angle. So if I'm just kind of drawing that off to the side so I can see it a little bit better, it's showing me that right here, this is a 72 degree angle, okay? And now I don't necessarily have to find the other angle. I can if I want to, but I don't need it. I could do everything with just that 72-degree angle. But if I wanted to find that other angle, of course, the three angles inside the triangle add up to 180. So this is going to be an 18-degree. And now from here, I need at least one of these sides. In order to use trigonometry to find a missing side, I need at least one other side. And so I have to go back over to this thing and say, well, if each side of this thing is 10 centimeters, remember what happens if I were to kind of drop a perpendicular line here, is that it cuts this into two congruent pieces, which means if that whole side is 10, each of these little pieces down here is going to be 5. And so if I come off to the side and label that on my triangle, that's going to be 5 centimeters. I didn't read very carefully. And what I can do with that information is now I can find any of the missing pieces. I could easily find the hypotenuse of this thing using trigonometry, and that would be the radius of the polynomial. I could also find the other leg of this triangle using trigonometry, and that would be the apothem. And so from here, I just have to decide, well, which of those things do I actually want? Well, the thing that I want is this guy over here. I want the apothem. That's what I need in order to find the area of this thing, okay? And so using my trig functions, I could say something like, well, if I use that 72-degree angle, I want the opposite side, which is the apothem, and I have the adjacent side, so that's telling me I can use my tangent function. So the tangent of 72 degrees equals opposite over adjacent, okay? And now I can cross multiply and solve this thing. So once again, on my calculator, let me pull up my other calculator so we can kind of see it. On my calculator here, I can go ahead and do the tangent, and make sure once again that your calculator is in degrees and not radians, but I can just do 5 times the tangent of 72 degrees. And I get 39. And we'll just round that off, so that's the apothem. Well, now I can find the area by saying, okay, the area equals 1/2 the apothem times the perimeter of this one. And the perimeter for this one, because each side is 10, there's 10 sides, the perimeter is going to be 100, okay? So again, this becomes a job for my calculator, 0.5 times the 15.39 times the 100. And actually, before I enter this thing, instead of doing the 15.39 here, I could easily do this without rounding it off by hitting the answer button so it uses my previous answer. Okay, so that's another little trick to make this thing a little bit more accurate and to save yourself from having to actually punch that in and type a little bit more. So I get a 769.42 and that's square centimeters. Okay, so again, there's nothing different about what we're doing right now. The only difference really is that instead of using something like a special right triangle to find the apothem, I had to use a trig function, okay? If I look at this guy, same kind of thing here. Notice I have the radius this time, but what I need is the apothem. And so as I kind of start to construct this, if I were to extend this side a little bit, okay, and draw that radius, and then draw the apothem here, which is the altitude of this triangle, that's the right triangle that I want to investigate. And so again, I always like to kind of take the triangle and draw it off to the side. We're going to be able to cut out a little bit of some of the work here. You don't have to draw all of the radii in this thing. And you certainly don't have to draw every single angle. We really just need to find specific ones. Okay? And so this is the triangle that I'm looking at. I kind of turned it a little bit and everything. All right? And now from here, it's all about the angles. I need to find the missing angles here. So as I look at this thing, 1, 2, 3, 4, 5, 6, 7, 8. It's an octagon. So I've got 8 sides here. So once again, as I talk about the angles, that's 180 times 8 minus 2. And again, I'm going to divide that by how many angles I have, because I want to find the measurement of each of those angles. So again, I do the 180 times the 6, gives me a 1,080. But now each of those angles, if I divide by 8, is going to give me a 35-degree angle. okay? And again, that is this entire angle is 135 degrees. Notice I haven't drawn as much here because, well, frankly, I don't want to draw as much, okay? The more I draw, the more cluttered it gets. Once I kind of narrow this down to the things I need, watch this, if I were to draw maybe another radius over here, if I know one of those whole angles is 135 degrees, I just have to divide it by 2 to get each of those smaller angles on either side. So like here, there'd be a 67.5 degree and another 67.5 degree, okay? And so that's what happens when I kind of cut this angle in half using a radius. And so I find that because, again, in my right triangle, that translates into this angle that's right down here, the 67.5 degrees, okay? And now from here, once again, I could find the missing angle, but again, I don't need it. Notice in the previous one, I only needed one of those angles. Well, that's all I need here. And so once again, I'm looking for the apothem this time, which is over here. It's that that leg that's got the perpendicular side to it. And so as I look at this thing, I have the hypotenuse, but I'm missing the opposite side from the angle that I'm given. So I want to use my sine function this time. So I'd say the sine of 67.5 degrees equals opposite over hypotenuse, so the opposite over the hypotenuse. And now from here, once again, I can cross multiply and solve this thing. And so again, let me pull up my calculator here. If I cross multiply and solve, I'm going to end up doing the 16.2 times the sine of 67.5. Okay? And it gives me a 14.97. And that's in inches. But now I have to plug this back in to get the area. So the area, once again, is 1/2 the apothem times the perimeter. And I can go ahead and just plug that right in. The apothem was the 14.97 times the perimeter of this thing. Well, I don't have the perimeter, and so this is another piece that I'm going to have to find. Okay? And so as I look at this, I can go back to this triangle again. And as I go back to that triangle, really I can find the perimeter simply by finding this side over here. I'll call it x. Okay? And so once again, if I use a trig function here, I have the hypotenuse once again, but I'm missing the adjacent side. That tells me to use cosine. So I could do cosine of the 67.5 equals adjacent over hypotenuse. And now once again, I can cross multiply and solve. Again, this is a job for my calculator. 16.2 times the cosine of 67.5. And I get 6.199, so 6.20 is what it rounds to. But now we have to kind of consider what that represents. That only represents a tiny little piece. It's not even the entire side, okay? That's only half of one of the sides, so you got to multiply this by 2. And if you want to get an accurate picture of this thing, once again, if I were to round this to 2 decimal places, it ends up rounding to a 12.4 for the entire side. But now there's 8 of those sides, so times 8. And notice, I haven't even written anything down here. I'm just doing all the work on my calculator. So right here, I get 99.19 for the perimeter, okay? And again, that's all thanks to using these trig functions to find the missing piece. It gave me a piece of that right triangle. Then I have to look at the piece of that right triangle in terms of how it's interpreted as part of the entire shape, okay? That piece of that right triangle is half of one of the sides. So I need to double it to get a full side, and then times 8 to get the perimeter, okay? Now as I go ahead and plug this into my calculator, again, we have this rounded off answer, which is going to be fine here. And so I get approximately 742.44. And that's square inches, okay? Again, it's possible that I could keep this thing in here without rounding anything off, but it would be a little bit of a pain. Like I'd have to keep the cosine of 67.5 times the 16.2 in here, and then times 2 for the side length, and then times 8 for this guy. And then as I plugged this in, I'd have to do 0.5 times the previous answer. And then if I didn't want to round off this other guy, I'd have to literally punch in 16.2 times the sine of 67.5, okay? And that's what I would get if I didn't round anything off. And notice the answer is slightly different, 242.29. And really, it depends on the context. For something like this, that slight difference isn't going to matter in terms of the overall area of this thing. Okay? So keep that in mind. We'll tend to use our rounded off answers to plug in. It is possible to keep it more exact until the end. And it kind of depends on the context. There are certain teachers and certain contexts in which, yeah, you don't want to round it off until the end. But in this context, it's fine to round it off to 2 decimal places and then plug it all into your calculator, okay? So we get a rounded off answer, all right? Instead of a 0.44, we should have technically a 0.29 there, okay? If I look at this guy, it says find the area of the triangle this time. So this time we're not going to be doing the 1/2 the apothem times the perimeter. That's reserved for regular polygons. This one I'm going to be using my area formula for a triangle, which is 1/2 the base times the height. Okay? And for this one, I have the base. What I'm missing is the height. So let's draw it. I have to draw an altitude in here because the altitude represents my height. And again, it has to go from the vertex perpendicular to the opposite side. But now I'm missing that piece. I need to find it. And to find this guy, if I were to once again draw this off to the side here, here's that right angle that I've drawn. And these are the side edges of my triangle. So just looking at that right triangle, well, I know that this side is 12 meters. I know that this right here is 48 degrees. What I want to find is the height here, h. And so once again, I'm going to use trig functions. And I look at the angle I have, which is the 48 degrees. From that angle, based on that angle, I have the hypotenuse, and I'm looking for the opposite side. Well, that tells me to use my sine function, okay? So I do the sine of 48 degrees equals opposite over hypotenuse. And now once again, I can cross multiply and solve for h here. So here it is 12 times the sine of 48 degrees. And I get 8.92. And now within the context of my area formula, well, that's 1/2 the base this time, which is the 21, times the height, which is that 8.92, okay? And again, for my purposes here, because I already have this punched in, I'm just going to go 0.5 times 21 times the previous answer, so I don't have to do any more typing. Okay, and it gives me 63.64. And again, that was me using the exact value for the height, and that's square meters. If I used the rounded off answer instead, ready, 0.5 times the 21. Oh, I missed the 0.5 here. Times the 8.92 instead. Notice it gives me a 93.66 instead, which that would be a perfectly acceptable answer here as well, okay? It all depends on when you round it off and how far you round it off. And if you round it to different decimal places than I rounded off, then of course our answers are going to be different, okay? Even if you rounded off the height to a different spot than I did, your answer is going to be slightly different, okay? And so, yeah, we want to build consistency, but we also want this thing to be accurate to certain degrees. And, you know, whether you're doing this in science or math class is going to change where you round things off. In science, they use significant figures. So it really just depends on the context, okay? For our purposes, either one of these would be a perfectly acceptable answer. All right. Just make sure you follow the directions. If the directions say, hey, round everything to 2 decimal places first before you plug it in, then do that. All right, and the idea there is because it'll make everyone's answers consistent, okay? And so follow the directions, follow the context in order to determine how you should be rounding these things, okay?